So we'll be doing a very small project in this today video, and into this project we are going to follow and revise the everything that we have learned from the day one. That is from starting from a sketch to using some basic 3D modeling tools, and also how we can convert our drawing or design to a detailed manufacturing drawing. So this is the step that we are going to follow. So if you have not watched any, or if you have missed any of the day session, just go and revise. As you can see, if you'll go into your dashboard, all the day contents are already uploaded into the dashboard. Apart from this, we'll also be sharing a playlist link. Since I asked into the group, I run a small poll into the group, and all of you was agree that I can share a public playlist onto my YouTube channel where all of you can easily access. So I did that, and I will be sharing that playlist also into the group. So all the time you have complete access to all these recordings, like all the day 7 recordings. And in this video, in today's session, we are going to start doing a very small mini project. So without wasting much time, since we are already on 8:13, and also somehow our connection just got restored, so I can see very less people are there, so no problem. So we will start from the project now. And again, I'm repeating, if you have any question at any point of time, don't wait. You can simply ask, right? You can simply ask with me if you have any questions. I will try to answer these questions right into this session, because this is the last session. After this, you will not be able to meet me during any kind of live stream. So it's important. Now, here you can see this is the steel pipe. Can you see onto my screen? Just see on my screen. This is the steel pipe that you can see. For this thing, we are going to design a small clamp today. And just within few seconds earlier, I had shown you what kind of okay, so yes, I will explain that as splines. When we'll go into the sketching, we'll explain that as spline, how we can control the spline angles. So right now here you can see this is the simple steel pipe. It's a hollow steel pipe for which we are going to make a small 3D printable bracket, and that will design into the Solidworks. So I already measured this pipe, and the diameter for this pipe is 28 millimeter diameter. So just note it down somewhere else. 28 millimeter diameter for this simple pipe that is hollow from inside. And for this pipe, we are going to design a simple bracket. So I will show you the bracket. Just give me a second. We are going to design this simple bracket that you can see that comes with the 2 holes at the base to mount it somewhere onto the place, and then a snap fit kind of bracket that we are going to design. Here you can see onto your screen this bracket. So this bracket is going to fit onto this pipe like this. Here you can see. So if you place it and press it little bit, it will fit onto this pipe. So it's a kind of a snap fit thing that we're going to design today. And if you want to open it, we can simply apply some pressure and we can attach it again. So this bracket I have designed inside Solidworks for this pipe, and then 3D printed using our desktop 3D printer. So this is the project, this is the design we're going to prepare today. Very simple design, but very easy for you to get started, to gain some confidence by doing this project, right? You will gain some confidence. So as I said, our pipe is 28 millimeter in diameter. So first we're going to model this piece of pipe into the Solidworks, and you can see. So the first thing, always we'll launch our Solidworks tool. So here is my Solidworks. Here you can see. Okay, some issue with my Solidworks. Let me relaunch it. So you just have to double click on your Solidworks icon. All of you can see my screen, right? Let me just check if I am sharing my screen. Yes. So what you can do, just double click on your Solidworks icon, and then it will start launching your Solidworks. All of you can see my screen, right? Just let me know into the chat box if you can see my screen. Just let me know into the chat box if you can see my screen. Write Y. Just write Y into the chat box. Okay. Thank you. Pawan, thank you so much. So here you can see we have launched the SolidWorks, and this time it is still connecting with the server since it's a cloud license. I have the cloud license of SolidWorks. So every time it checks inside the server whether my license is active or not. So right now it is just connecting, but somehow my SolidWorks just got launched. And now the first thing that we'll do, we'll create this normal steel pipe that you can see of diameter 28 millimeter. We are not going to worry about the internal. Yes, Sundaram, do you have any questions?
Yes, sir. Screen mirroring is not prominent.
Screen
SolidWorks
is
not show.
okay. Screen is
Minimum
not visible.
setting. Okay, sir. Yes, sir.
Can you see my screen now? Can you see my screen? Hello, everyone. Can you see my screen? Anyone from the audience, can you write just whether you can see my screen? Just write Y if you can see my screen. Just write Y if you can see my screen. Okay, I can see people are seeing my screen. So maybe you have to configure at your end. So if you'll see on the camera, I have this steel pipe that we're going to model. So it's a simple cylindrical steel pipe, nothing very unique. It's very common steel pipe that we're going to do today. So first, what we'll do, we'll go onto the file tab, we'll click on and launch this new part file, right? Because one cylindrical pipe is a single part file. So we'll start with the part file, we'll click on OK, right? And if you remember, I told you the diameter is 28 millimeter for this pipe, right? Diameter is just 28 millimeter. So what we'll do, we'll go on to the sketch tab, because if you want to start something into SolidWorks, we'll have to start from the sketch. So we'll go on to the sketch tool panel and we'll activate this sketch tool. We'll activate this sketch tool, and then we have to define the plane onto which we want to create a sketch. And as I told, you don't have to worry about the first plane that you have to select. You can select any plane, you are free, right? Just don't worry when you are just getting started. Simply select any plane. This time I will select front plane to create our sketch. So I will click on the front plane, and now my front plane is active in front of me, and it is also all the sketch tools also got active. So I can start creating a sketch onto this plane. And this red dot that you can see on the center of the screen is called origin. So this is the origin. So if you'll zoom in and zoom out, you can see the origin size is not changing because this origin size is parametric. It will automatically adjust based on our movement of the cursor. There you can see. Now I will move my cursor to the sketch tool space, and there I will activate this circle tool. I will expand, I will activate this simple circle tool, not perimeter circle tool, simple circle tool. So I activated the tool, and once I activated the tool with my cursor, you can see it, the shape of my cursor just got changed and a small circle is attached with it. This means I can start creating the circle. And to create circle, you have to define two things. The first thing is the center point of the circle. Second thing, you have to define the diameter or the radius of the circle, right? So first I will define the center point, and center point I will start from the origin of this drawing here. So it is automatically snapping whenever I am moving near to the origin. Here you can see. So once it is snapping, I will click and drag outside. So what is the radius that we want to keep? If I remember, not sorry, what is the diameter? So first I will create a random rectangle of any size. I don't know the size of this rectangle. So if I'll click on the perimeter of the circle, at the bottom you can see it says 10.85 diameter, right? So it's completely random. So to make it this circle in perfect size, we'll use the sketch dimension tool. So we'll go on to the sketch tool panel again, and there just after the sketch tool, there is a tool called smart dimension. And if you'll expand that tool, here you can see we have different kind of dimensions, right? Dimension tools. I will simply activate this smart dimension. Now, once my smart dimension tool is active, I can click anywhere onto the perimeter of this circle and drag outside, and it is giving me the diameter of the circle. Right now the diameter is this much. You can see the numbers are not correct. It's 10.852299593. So we don't want to keep such kind of number, right? We want to keep 28. So we'll change this value to 28, sorry, 28, and we'll click on this finish icon, so it will accept the value. Now you can see the diameter of the circle just got updated to 28, right? Once we are done, on the left side simply click on finish, right? So once we are done, just click on finish or press escape on your keyboard to come out of the tool. So this way what I did, I had created a simple circle of diameter 28. Now since I want this circle to be hollow, so first I will convert this to 3D. So I orbit it little bit using the mouse like this. I can orbit it, I can rotate it. So I orbited it little bit like this, so I can see it in a kind of 3D view. And then we'll go back to the features tab, right? I will select the sketch first, because in this sketch one I created this circle, right? So I will select the sketch one first, then we'll click on this extrude tool to convert our circle, flat circle sketch to 3D. I will click on extrude, right? And the moment I will click on extrude, here you can see it's extruding in both the directions, right? So I will enter some value. Let's say the value is 35. This is the length I want to keep, just 35, because even it's this steel pipe, you can see it's not very long, it's very short in size. And in 3D model, we are keeping it even shorter. So we'll just keep 35. I will click on finish. So this is the cylindrical piece we have created, for which we are going to design this bracket, this snap fit bracket that you can see. If we'll try to fit this bracket onto this one, it simply snap fitting, and then it also have the two holes at the base, right? So on these two holes, we can also mount this on some place. So this is a kind of fixture, you can say, or what you call it, jig or fixture. I don't know, I don't have much idea about jig and fixture. So this is a kind of thing that you can design. So now here you can see we designed a small cylindrical pipe, but it is completely solid from inside. And how we can make it hollow? Anyone have any idea? If you have watched all the sessions till today, how we can make it hollow? What is that tool that we can use? Just write into the chat box, what is the tool that we can use to make it hollow? Anyone, if you know what is the tool, just write it. Right or wrong, whatever you think, just write it. Right, come on, right. Anyone knows how we can make it? Cell tool. Yes, you are right. Cell tool. By using cell tool, we can make it hollow. Anyone else have any idea like how we can make it hollow? Right. So okay, so we have multiple ways we can make this tube hollow, but the best way is the cell tool. Yes, Naidu is right. The best way is to use the cell tool. So in SolidWorks, if you'll go on the 3D tool panel, there is a tool you will be able to find that says cell. Can you see that? SHELL, cell. So what it does, it will hollow out your body, solid body, following a specific thickness. So the moment I will activate this cell tool, here you can see the first thing that will change is the parameter. So I just want to keep the thickness, let's say 1 millimeter, 1.6 millimeter. So I change the thickness to 1.6 first. Then I have to define the face, right? Face that we want to keep. We want to remove. So these are the two faces we want to remove. And if you'll click on show preview, you can see the preview that it's getting hollowed out, right? So these two faces I want to remove. That's why I selected these two faces, face 1 and face 2. And I am keeping a thickness of 1.6. And the moment I will click on finish, here you can see this tube just got hollowed out by a thickness of 1.6 millimeter. So, and on the design tree also, this cell tool that we have used also got recorded, right? So all the time you can come onto this, you can click on edit feature, and you can change the thickness. Let's say I want to keep 2.5. So I can change that value. With the moment I'll click on finish, here you can see the thickness just got updated to 2.5, more thicker. So this is the way you can sell anybody. So this is the first object we have created, right? I will simply click on save. I will save this file with a new name, and that name, you remember, since it's a pipe, so I will just write it cylinderic, cylindrical pipe. So we have just given it a name, cylindrical pipe. I will click on save. So this is the first part file. We have created a simple pipe of diameter, how much? 28 millimeter. Outside diameter is 28 millimeter. And we had used the cell tool to make it hollow from inside by keeping a thickness of 2.5 millimeter. Right. Now I will close this part 5. I will close this part 5. Now, since our pipe is ready, now is the time to start designing this bracket and how we can design this bracket. How we can design it so it can snap fit onto this pipe like this. So you can see, you will see now. So what we'll do, again, we'll go on to the file menu and we'll click on this new option to start a new part file, because the bracket is a different part. The cylindrical pipe we created is a other part, whereas the next thing that we're going to do is the bracket part. So this is the thing that we're going to design now. So we'll again select the part option over here. We'll click on OK to launch an empty part file first, and then inside that part file we can start adding the features. So to start creating the bracket for a pipe, what we'll do, first activate the sketch tool, click on the create a sketch tool and select the plane. So this time, instead of selecting the front plane, I will select this top plane, this one, top plane. I will select the top plane. Now I will activate my circle tool. By origin, I will create a circle like this. And this time I will create a circle of diameter little bit lesser than the pipe. So how much is the diameter for the pipe? That was 28. So let's make it 27.6 millimeter. I will press enter. So this is the diameter of a new circle we created for a next part that we are designing, and we'll also save this one. So we'll save this part file with a name. Let's write it bracket. So bracket bracket, and we'll click on save. So here you can see the name just got updated. Also, all the time we are following this millimeter gram second system of units. So these always also you have to take care of. So what I did, I created a circle of 27.60 millimeter. I will click on finish. So to accept the dimensions. So this is the circle we created, right? Now, before moving forward, we'll go back to the normal of this sketch, and then we'll start adding features. So let's say this is our pipe onto which our bracket is going to fit. And why we kept it little bit smaller? Because we want a tight fit. We want a tight fit. We don't want loose fit, right? We want our bracket and this pipe should be fitting tightly. Here you can see it's fitting very tightly, and you can see just a click sound is coming because the fit is very good, right? So this is what we are going to do now. So what we did, we had created our shape of the pipe. Now the next thing is that we also have to create a base, and that base is rectangular. So we'll go on to the sketch tool again. In the same sketch, we'll go to the rectangle and we'll select this rectangle that says center rectangle. We'll activate this tool and we'll move our cursor near to this. So whenever it is in front of this origin, I will click and will drag and create a rectangle like this. So here you can see what we are doing. We are creating a simple rectangle, right? I will drag this line little bit towards the bottom circumference. I will select these two origins and will apply the vertical constraint. So both of them align perfectly in the same orientation. I will click on finish. Now I will also dimension it from this point to this point. I want to keep a dimension of 18 millimeters. So I will write the values 18. Also for the base, the thickness of this base, I want to keep 6 millimeters. So we'll enter the value 6. Here you can see. Now we'll also enter the width of this piece, and the width we just want to keep 16. So I will enter the value 16. Here you can see. So this is what we did so far. What we did, we have simply added few features onto the base. Now, before moving, I will activate the line tool, and from this corner point to the circumference of the circle, I will connect like this. Like this. Here you can see what I did. I connected using this simple line tool on both the, like this. Here you can see I have to connect this one as well. Yes, it got connected. It got connected, right? This is not connected. So we'll make this line vertical, select it, apply the vertical constraint, right? So here you can see what we did. We had connected this using this simple line tools over here. Now we'll go to the normal of it. We'll also change this to vertical, finish, We'll also change this to vertical, finish, like this. There you can see. So what we did, we had connected this using this simple line tool, and this is connecting on the other end, right? Now the next thing is that we'll go back to the normal. We'll activate a new tool inside a sketch panel, that is the offset tool. And what offset tool does is it will create a parallel or equidistant entities of your existing entities. For example, if I'll activate this offset tool, and now if I'll change this offset distance to 2.4, here you can see 2.4, and the moment I will click on the circle, it is creating another circle that is 2.4 millimeter away from the existing circle. Right. If we'll reverse the direction, we can also reverse it like 2.4 millimeter towards inside, but we want to create towards outside, so we'll keep this option. We'll click on finish, so here you can see. So this is the shape we got. But if you want to fit a pipe into this design, we also have to make an opening onto the top, so from where we can insert our pipes. For example, if you'll see the bracket, here you can see at the top area here, there is opening. From this area only the pipe goes inside the bracket, right? So for that, what we'll do, we'll activate the line tool, and we'll create a line like this. Here you can see. We'll create a line like this, simple lines like this, and we'll make sure that these lines are equidistant from this origin. This distance we'll have to maintain, right? So let's maintain a distance of, since the diameter of the pipe is 28, so we can easily maintain a distance of, let's keep it 12, right? So we can keep it 12. And on the other side also, we have to add this dimension. Just activate the smart dimension tool, select the origin, select the line, drag outside, and enter the value 12. So here you can see we added two lines equidistant on both sides. And if you'll see over here, if you'll add these values, the total opening size is 14 millimeter, not 14, sorry, 24 millimeter, right? And the pipe diameter is 28. So if the pipe diameter is bigger, definitely it is going to have little bit of friction while going into this slot, right? And it will hold the pipe also. So that was the theory behind it, decreasing the opening size so it can hold the pipe diameter into the bracket. So this is what we did over here, right? We added these lines to make a opening a little bit smaller, right? Smaller than the diameter of the pipe, and that is the important thing. Now, since we are done with the sketching, we'll click on the finish sketch, right? Now, the first thing that we want to do is one more thing. We did a small mistake. We'll go back to the sketch. We'll click on the edit sketch, and here instead of 16, we just wanted to keep it 30, right? So it's giving me an error. So we'll solve that error. We'll delete these lines. Maybe because of these lines, we are getting that error. So we'll change the act to 30 like this. Here you can see. Now it is good, or maybe a little bit more, 40. Here you can see. Now I will click on finish. Since we are done with the sketching part, I will go back and select the sketch. We'll activate this feature tool. We'll start extruding. We'll activate the extrude tool. Now we'll select the profile that we want to extrude. So first we want to extrude this profile. So I selected that profile, also this base one. So here you can see this is the profile that is getting extruded, but we don't want to extrude it into this direction only. We want this to be symmetric. Means if this is the sketch plane, this should be extruding in both the direction in an equal manner. For that, what we can do, we can change this to, or we can keep this one as direction, right? We can keep this as direction 1. Here we can enter the value. Let's say I want to extrude a total thickness of 16 millimeters. So I will change this to 8. I will also turn on the direction 2, and this one I will also make it 8, right? And here you can see it's extruding in both the directions symmetrically. Now I will click on finish. Here it is. So this is the pipe. This is the portion. This is the portion that you can see over here where the pipe is going to fit. Now we have to work on the base, rectangular base. So for the rectangular base, I think again we did some mistake. The sketch earlier was the right one. So we'll go back and we'll click on edit sketch, and instead of 40, we'll change this to 16 like this. I will click on finish sketch, and here you can see the moment you will first extrude any of your first sketch, your sketch will get hidden. So how you can bring it back? Simply go and expand your extrude folder, and on the sketch make a right click and click on this show this sketch, and the moment I will click on show this sketch, all sketches are again visible. Here you can see. Now here we'll again select the sketch and click on this extrude, and this time I just want to extrude this rectangle, right? So activate this option that says selected contours, and then specify your rectangle that you want to extrude. So I will select the complete rectangle, not just the portion of it. So here you can see complete rectangle just got selected, and I want to extend it by 20 millimeter, and also on the other side also we want to make it 20. So in both direction it is getting extended by 20 millimeter, and is also getting merged with the existing body. It is also getting merged with the existing body. Both the body just got merged with each other. They are all merged, right? They are all combined. Now here you can see bracket with such kind of thing. Now I will make a right click on the sketch, will hide it because I don't want to see that sketch now, because that was more kind of disturbing. Now onto this base I want to add holes, and that hole is, if you know, we can go to the hole wizard, into the features tool panel, we'll go to the hole wizard, we'll activate the hole tool, we'll click on the hole tool, and the moment we'll click on the hole tool, we will be able to see a window like this onto the left side. Just go on to the positions, right? Click on the face where you want to create hole, then define the first point and then the second point. So these are the two holes we want to add. Now these hole sizes are a little bit bigger, so don't worry about that. First dimension it. So first I will dimension it from this origin to this origin. It should be I think 14, right? And also we'll do the same on the other side using the same dimension tool. From this to this I just want to keep 14. I will press enter. Here you can see. Now I will click on finish. I will also make sure that all 3 points, all 3 origins are vertically aligned. So I selected all the 3 points. Here you can see. By mistake I also selected a face, so I will delete that. I will press escape. I will repeat it. I will select all the 3 origins like this. We'll apply this vertical constraint. We'll click on finish. Now you can see all things are fully defined. Now we'll go on to the type. First, I want to make a countersink hole. So we'll select this option, countersink, right? Next, I want to keep the standard as ISO for this hole. I want to keep the top flat. I want to change the size to M4. I want the holes to be a little bit bigger, like for the M4 screw sizes. And I will make sure that it is truly cutting the body. Here you can see it's truly cutting the body. I will simply click on finish. And the moment I will click on finish, here you can see hole just got created. So we can screw a countersink hole onto this base wherever we want, right? Still, there are so many things that we have to improve into this drawing. For example, these sharp corners. Let's apply some chamfer onto all the 4 corners. So we'll go on to the fillet tab. We'll select this chamfer. Then we'll select all the edges where we want to apply chamfer 1, 2, 3, and 4. And we'll enter the chamfer distance. Let's say I want to apply a chamfer of 2 like this. I will click on finish, and here you can see. Now the things look much better. Apart from this, we also want to apply some fillets. We don't want to keep these edges this much of sharp. So we'll activate the fillet tool. We'll select the edges where we want to apply fillet, this, and we'll give it a fillet radius of 0.4 like this. Here you can see the preview. I will click on finish. So this is what we got. More kind of optimized design. Still it looks very simple. So we'll also apply fillet onto these edges. So we'll activate the fillet tool again, and we'll also select the complete face. So we will be applying fillets onto each corners like this. Let's apply a fillet of 0.4 thoroughly. 0.4 mm throughly, so the things will be more stronger. Like whenever you apply a fillet, you are avoiding a sharp corner, and most of the body in practical fails because of the sharp corners or edges only. So always try to avoid sharp corners, apply at least some amount of fillet. So here you can see we have applied some fillets onto this. Now is the time, now is the time to show you something very unique. So now we are done with this part, and this part can be 3D printed because we have already provided a option for the holes at the bottom, and also a place where pipe can snap fit like this, that you can see onto your screen right now. Snap fit like this, right? Here you can see this is fitting, and we can simply remove it just by applying little bit of force, and we can apply it like this. So it's kind of a very important design that we can use on regular basis, right? So now, since we are done with this part also, we'll click on save, right? We'll click on save, we'll close this one. Now let's move back to the assembly, and we'll show you how you can insert standard components into the assembly. So let's first start an assembly file. We'll go back to the file, we'll click on the new, and there we'll activate this assembly file. We'll click on OK. So the new assembly file is just getting launched, right? Here you can see this is my new assembly file. The first, we'll go on to the assembly, we'll click on the insert component, and we'll insert our first component, that is the bracket. So we'll find our bracket file, we'll click on open. So right now my bracket is not in correct orientation, so we'll rotate it little bit along x-axis and little bit along y-axis. So now it is in correct orientation. I will turn on the origins so I can match it with the origin, and will move my cursor near to it and will click. Here you can see origin for both of them are matching. So now I can turn them off, right? I will make a right click, will click on fix. So it just got fixed onto the space. Now the next thing that we have to bring is the pipe that we created. So we'll go on to the insert component again, we'll select that cylindrical pipe, we'll click on open, and the pipe, here you can see again the pipe is not in the right orientation, so we'll rotate it little bit like this. So and then we'll place it near to the opening. Now you can see the things are not optimized. So what we'll do, we'll apply this mate, right? We'll apply this mate option, we'll select the face of this pipe and the face of this bracket, and now they both of them just got aligned, right? I will click on finish. Now this can move freely into this slot because we have not applied the second mate to define the position of this pipe. And for that, what we'll do, by pressing shift on my keyboard, I will select all these four faces, the two end faces of your pipe and the two end faces of your bracket. So here you can see I have selected all the four faces. And once you have selected all the four faces, just activate your mate tool, and it will simply apply a symmetrical mate onto your body. Here you can see now your body is symmetrically aligned between that slot, between that clamp, right? I will click on finish, and here it is. Now since we had fitted it correctly, I will click on finish. Now before we insert this pipe into this clamp, we also have to put the screws onto these two slots, right? So first we'll hide this cylinder that we just added. We just made it hidden, it's not removed, we just made it hidden. Just right click on the component and click on this hide component option, and if you want to bring it back again, right click on it and click on show component like this. So these little tools will make your work very easier when you are working in SolidWorks. So now is the time to bring the screw, right? And for that we'll go back to these options that you can see over here, and there we'll find an option that says design library, right? So inside design library, you will be able to find all the standard components like screws, nuts, bolts, washers. So these are standard components, and these are pretty common in all the countries, like the sizes and everything. And that is what we're going to insert, because the hole, when we created this hole, we followed the ISO system, and we had used the M4 countersunk screw, if you remember. So we had created hole for that screw. So the same screw will try to find into the toolbox. So we'll go to the toolbox, we'll look for the screw. Let's write a screw, SCREW, screw. I will search it, and here you can see our toolbox is not added. So I will simply click on add in now, I want it now, and it will take few seconds. It will keep adding. So here you can see my toolbox just got added. I will go to the ISO, right? Inside ISO, I will go for the bolt and screw, right? In bolt and screw, I will go for the countersunk. So let's find the countersunk. So we have to find the countersunk screw. Yes, here you can see the hex socket countersunk head screw, right? But we need self-tapping screw. So let's use this for this moment. So I will click on this screw, right? I will drag it and I can bring it into my design. Here you can see like this. I can bring it into my design. But moment I bring it, you can see the size is not correct, right? The size is not what we expected. It's smaller. So the moment you dragged it inside, on the left side, right? On the left side, you can see it has all the options to change the size and length of this screw, right? You have all the options. So what I will do, I will go and change the size first. Let's change the size to a little bit bigger, so it matches to your hole size. So it's super tough because the standard is not matching with our intended thing. So we'll go back. Instead, we'll search for the countersunk and here is the slotted countersink head wood screw. No, this is not the right one. We have to look for the, let's go to the Indian standard bolt and screw countersunk head. Yes, then we only have these two options for the Indian one. Okay, let's take any one. Let's take this one. I will drag it. So the moment you will simply place it near to the hole, it will automatically, you can see it's snapping, right? You don't have to apply mates or anything. And it is also detecting the size based on the hole. That M4 should be applied over here, right? So once you are done, you can simply click on finish. Yes, that is the screw. Now the tool is still active. You just go to the next hole and just click anywhere onto the face of the countersunk hole and it will snap that as well. So here you can see both the screws we have applied. Now I will simply press escape to come out of the tool. So these are the two screws that we have applied, right? So if you want to edit this part, you can make a right click and click on edit part and you will be able to make edits into this part, but that is not recommended. So now here you can see these are the two screws that we inserted, but again you can see there is a small problem. And what is that problem? The problem is screw length is not right. You can see over here the screw length is not right. So by dragging these thing, we can change the screw sizes, screw lengths. So for this screw here, you can see the screw length is not right. Just select the screw and then drag this feature to change the screw. So this is for 10 millimeter, this is for 12 millimeter, this is for 16 millimeter. I just want to keep 10. So I will keep like this. So here are two screws and they are not showing the thread onto the screw just because so SolidWorks works easily, because whenever you are using tools like this, it takes lots of processing power, and if you keep adding features onto lots of fasteners, it will make it slow down. That's why they have not added cosmetic threads onto these screws. But again you can see okay, so who is doing this thing? BP. So you did something, right? Let me remove that, guys. This is not right. Anyway, so this is how you can insert component into your design or assembly. You can see we added two fasteners, standard fasteners. We created this bracket. We also added a pipe that is hidden at this moment like this. So it has multiple part assembly. Right now we can say it's a multi-part assembly. Right now, once we are done with this assembly, we can simply click on save to save this assembly into our folder. Let's write it I just give it given it a name BASS, right? I will click on save, and this assembly just got saved. Now is the time to create drawing from this. Simply go into the file menu, click on the make drawing from assembly, right? So it is very simple. I simply click that, and from the last session, if you remember, first thing you have to do is select the paper size. I will select A3, will click on OK. It will automatically bring the A3 paper size with a default title block, and on to the left side, if you'll go on to this view palette, from there you can drag the views. Let's drag isometric view first. So this is the isometric view. Now the scale is very smaller, so I will click on finish. I will click on the sheet properties, go into the edit sheet format, will change. Sorry, I have to go to the properties. Sorry. So I will make a right click onto the sheet. I will go on to the properties, and from here I will change the scale to, let's change the scale to 4:1. Apply changes, and this is the right size. I will bring it little bit onto the empty area, and then I will select it and will change the visual style for this assembly to this one. Right. Now I will go on to the annotation tab. I will click on auto balloons, and it will once I will select this assembly, it will automatically apply balloons. So here you can see it has two parts. The first part is cylinder, the second part is the clamp that we created. Now the fasteners are not getting counted over here. We'll go on to the tables, we'll click on the bill of material, again we'll select the assembly, and then we'll click on finish, and bill of material is getting added. So inside bill of material, you can see it says we have one bracket, we have one cylindrical pipe, and then we have two screws, countersunk screws of M4 size with 10 millimeter length, right? So we have all the details. Now we can adjust. If it is not fitting correctly, you can adjust little bit like this. The column sizes for this bill of material easily just by dragging your like an Excel file, right? So this is the thing we added. Now let's start creating the detailed drawing for the part files now. So this was for the assembly file, so I will click on the save. So this was the simplest for the assembly file. Now let's save it. We'll go and expand the part files. So let's first create drawing for this bracket file. So we'll select that part, we'll make a right click, and we'll click on open part, this part as a separate file. So it will open it. Like here you can see it just got opened. Now I will go on to the file menu and will click on make drawing from the part, right? Again we'll select the A3 paper size. We'll go on to the view palettes, and we'll start dragging the views. So this is the front view, right? And this is the side view, and this is the top view, like this. Once we are done, we can simply click on finish. We'll select the parent view, right? We'll select the parent view, and we'll change the visual style to this one. So we can even see the hidden features, right? Also, we'll edit the properties and we'll make it a little bit bigger in size, maybe 3:1, like this. Here you can see. Simple bracket with all the details. Now is the time to start adding dimension. So we'll activate our smart dimension tool. First, we'll input the inside radius of the circle. Then we'll enter the value for the outside radius of the circle. Then we'll enter the values for the distance between this and this should be 24. If you remember, we kept it 12 mm from both sides. And then we'll also add few more dimensions, like from the center of the circle to the base. This should come 21, like this. And we'll move this dimension a little bit towards upward. So, and whenever you are placing dimensions, try to make it in place in a manner so the things look more kind of professional. Right here you can see I will enter the value for the base at 16. I will also enter the value for this height of the base at 6 millimeter. So these are all the things we just added. Apart from this, rest of the things we are going to provide in other views. For example, the base width, if you see from this edge to this edge, this is 14, right? And also we can add few more dimensions, like the width of this bracket onto the top that will hold the the pipe piece from here to here, we just want to keep solar, and we just want to keep, this is the measurements we have used while creating this design or drawing, right? And now let's add few more dimensions over here. So we'll activate this whole call out, and first we'll name this hole size. So there are two hole sizes here. You can see 2 into 5. This means this one and this one. 2 into 5, 4.5 is the hole size, and the depth is 9.4, right? And also the angle is given over here. That means it's a countersunk hole, right? Now, just give me a second. Now let's add the distance between the hole using the smart dimension tool. This hole to this hole, the distance is 28 millimeters. So they are symmetrical on both sides, right? Just by these values, we can confirm the size of our holes. Also from here to here, if you can see, it's 16. And if you'll expand the smart dimension tool, at the bottom you can see the chamfer dimension. And if you remember, we have applied chamfer onto the corners. So we'll select this chamfer and then the base, and it says we have applied a chamfer of 2 millimeter distance, and the chamfer angle was 45. So this is applicable on all 4 corners. If you remember, we have also applied small fillets, right? So if we'll zoom on to the areas like this, here you can see, we can see that fillet, and that fillet is 0.4 millimeter for all the corners, right? 0.4 millimeter. So these were all the dimensions that was needed to define this drawing or design. And what we can do, we can go back to the drawing space again. We can click on the projected view, and we can click on this parent view and drag and create one isometric view also. And once you are done, you can click on finish. And since I don't want to keep this isometric view this much bigger, so I will simply select it. We'll change the scale of it by using custom scale to 1:1. Let's make it 1:1. Here you can see more smaller, or maybe a little bit higher, 2:1. Let's make it 2:1. 1:1 is getting, also will change the visual style to this one. Here you can see. So this is just by seeing this drawing, anyone can have idea like what kind of part it is, how it looks like, and they can easily also find all the values, like all the measurements. I have provided the hole sizes, the hole locations, the thickness of these clamps or the brackets, the opening onto the top, the size of the base. So it has all the information almost, right? Here you can see the chamfer angle is also provided, chamfer values and the fillet values. So this is the drawing that is ready. And once your drawing is ready, what you can do, go into the file menu, click on export as, click on export as, and the moment you will click on export as, you can export this drawing as a PDF file. Just export this drawing onto your desktop or anywhere you want to save, and the moment you will export it, it will take few seconds to process. And once it is done, here you can see this is my first PDF file we just created from our drawing file, right? We started from complete assembly from the scratch, and we got something like this. Now anyone have any questions? Just let me know into the chat box, because we are done with this design and with almost every design. And when I exported this file as a PDF file format, at the bottom you can see it says Solidworks Makers product for personal use only. Why? Because I am using a cloud makers license that can only be used for personal or for educational purposes. There is no need to convert lines into polylines in SolidWorks like we use in AutoCAD, because both software have different purposes, right? SolidWorks have different purposes. It is for basically 3D, and whatever the sketch we are creating just to support our 3D objects. But in AutoCAD, you only work with 2D geometries. So that's why they are converting lines into polylines are important. But here, the concept is completely different. You don't have to think like that. Just start with the entities, simple sketches, simple circles, simple rectangles, and then you can start building the object slowly. So this is how things are done, right, in 3D software. Also, I forget one thing. So some of you have asked about the polylines, like how we can create it, right? So if we'll go onto the sketch, let's say I want to create a sketch onto this face. So I will activate that. Now inside the sketch tool panel, here you can see there is a tool called splines, right? So if we'll activate this spline tool and if we'll start defining the points, we'll get a spline like this. The moment you will keep defining your points, you will keep getting splines like this, right? And if you'll once you are done, simply press escape. So here you can see, and all the time if you'll adjust these points, the shape of your spline will adjust accordingly. So these kind of splines are really important if you are working as a surface designer, or if you are designing something using the surface, complex surfaces. So here you can see. Now how you can control these points. So simply select the point, right? Okay, so someone was asking like how we can control the what was that question? Let me just check. Can you explain spline angle controlling? How you can control the angles, right? So see, to control the angles, I don't think they have any options inside SolidWorks. Let me check. I have seen that option in Autodesk Fusion. You can easily control the direction of your spline, but I cannot see it here. I cannot see it here. Okay, so maybe that's possible because we have created a normal spline. So let's delete this one. If you want to control the angle of your spline, activate this style spline. And then style spline is also the same thing, but you have the control of the angle of your spline. Here you can see. Now, what you got just by controlling the angle of these lines and the points, you can control the shape of the spline also. If you change the position of these points or the angles, you can see the shape of the spline is also getting adjusted. So by using these options, you can do that in SolidWorks, I think. Okay, so Pawan is asking about the relations, right? So relations are simple. I told you, once you have multiple entities, let's say we have this circle and we have this line, right? And now if I want this end point of this line to be touching to the center of the circle, so we have to apply a relation that is coincident, right? So to do that, simply by pressing shift on your keyboard, select both the points. And the moment you will select, on the left side, you will see that relations are visible. Like what kind of relation you want to apply between these 2 points. So I want to apply coincident. So the moment I will click on coincident, here you can see that point just got shifted onto the center of the circle. Right. So once you will select the entities, select the edges, select the points, then only you will be able to see that options to apply relations onto your left side. Right. Anyone else have any questions? So let me know into the chat box, because this is the last session, and once this session is over, we are not going to host any live tutorials or anything. You will only be getting the recorded contents and support in the group, right? Support in the WhatsApp group. Also, I will be sharing the playlist today, the complete playlist, from where you will be finding this complete recordings that you can easily access, because some of you were having trouble in finding the contents. That's why I thought, let's share. This is my YouTube. Here you can see this is my YouTube. We have uploaded more than 538 videos. We are also close to 4,000 subscriber now. So this is the playlist that I uploaded, but that this was not public earlier. Now I started making it public as per your request. So in this complete playlist, if we'll go to the complete playlist, I don't know how we can do that. Just a second. We'll go on to the playlist. Here is this playlist. And this is my SolidWorks bootcamp playlist. So if we'll open that, it has all the 5 days recording already uploaded. So day 6 and day 7 is pending. That will be uploading very soon. So I will simply copy this playlist and will share it with all of you. So I will copy this playlist. I don't know if I can share. Let me just check how we can share. We'll go on to the playlist. And again, guys, if you have any questions or any doubts, please ask, because this is the last session, guys.
Sir,
Please ask.
template you add the website, sir.
Sorry.
Template.
Okay, what template?
Last the A3, A4.
Okay. So when we start,
A3,
when we,
A4.
okay, got it. So see, just
Yes,
let me
yes,
open
this
the,
one, sir.
yeah, see.
Yes, sir.
Uh,
A3, A4.
it,
You added the website.
yes,
I
all the
download, sir.
time, whenever you will import the template, there the page size will be written. This is A3, right? And if you want to
Okay,
change
sir. Thank
it,
you.
if you want to change it, simply go onto the sheet format, right? Go onto the sheet format, make a right click, right? Click on, go to properties, and there you have an option to change it. Like if you want to make this to A1, select it, click on apply changes, yes, and you can see the paper size just got updated, but our views are still in the same scale. So we have to adjust our views also. So it's really important that whatever the page size you select, accordingly you have to select the scale of your different views. Right. This is how you can do. Any more questions, guys?
Okay, sir. Okay, sir. Sir, this batch, next batch, will which class you started, sir?
Sorry.
Next batch, which class you start? The first batch of classes in SolidWorks, sir.
Uh-huh. So the next batch
Your
will
understanding?
be on SolidWorks only. New batch is going to start on AutoCAD. I don't know how many of you have are aware of it. So the new batch is going to start, not this one, Academy one. So if we'll go on to the courses, a new batch is going to start about AutoCAD, but the language will be mix of Hindi plus English. That is going to start from 23rd of August. So this is about AutoCAD, where we'll be covering everything about AutoCAD, and this will be little bit longer of 2 week, because AutoCAD is not a very small software. It has more tools than SolidWorks, more tools, features. That's why we are taking more longer for this bootcamp. So this is going to start this month, and so if any one of you are interested, you can check it out onto our website. And batch 2 for this same SolidWorks is going to start maybe the next month, because this month we have few projects that we have to finish.
Okay, sir. Same another class, sir. SolidWorks, next month you started.
Yes, the next month same kind
Just
of
advance
sessions
one.
will start.
Same classes.
Not 10 classes. Again, there will be 5 classes, but in the next session we'll also have some recorded tutorials as well. So means well planned recorded tutorial, not the recording of live ones.
Okay, sir. Okay, sir. Thank you, sir.
Anyone
AutoCAD I
else?
will join, sir.
Okay. Anyone else have any questions?
Sir, would you please tell me what is the basic model of laptop we need to run SolidWorks? It means
See,
how much
yes,
RAM it needed and the graphics card details.
I got you. So actually means the system that I am using right now, it's a Core i5, I think 10th generation processor with 16 GB of RAM. Earlier it was 8 GB, but I expanded it to 16 GB of RAM with a graphics card of 4 GB and 1 TB of SSD, kind of like either you can use hard disk or SSD. But if you'll just search on the internet, SolidWorks recommended configuration, PC configuration, or laptop, just search configuration. Just search for hardware configuration. So they also have standard recommended configuration. Here you can see the system requirement for SolidWorks, and this is what SolidWorks suggests, that it should have Windows 11. Like if these are the versions, based on that they are suggesting. So you should have Windows 11 or 10 at least. You should have, like if you are working on Windows, Then these are the hardware configuration requirement, right? Either it should be Intel or AMD. So this is the configuration. RAM should be minimum 16 GB. 32 is recommended, but it works on 16 GB. It should have SSD at least for few GB, so your system will be much faster. So this is the recommended configuration from SolidWorks, official SolidWorks, but I am running SolidWorks below their recommended value as well. So that's not an issue. At least it should have decent PC, because Core i5 is the minimum requirement in 2025. And if you're still running i3, then it will be little tougher for you to run 3D tools, basically. Tools like SolidWorks or UGNX or CATIA. You will find some trouble. So get at least Core i5 processor and at least 16 GB of RAM to get started. You can easily run assemblies of around 500 parts, like that.
Sir, I want to go with HP Vector's Ryzen 5. Is it okay, sir?
Yes, is it okay? But actually, I do not recommend Ryzen processor, and the reason is because for Dassault system softwares, it's okay. For example, here you can see they are recommending Ryzen, right? AMD processors, right? AMD 64-bit processors. But in case of Autodesk softwares like AutoCAD, and if you want to run some graphics software, then like if you want to run Blender or anything, there could be some sort of issues. So if you are spending like more than 50K, or if you are spending more than 40K for a laptop or PC, then buy Intel one. Why you want to go with the AMD? That could be risky, I think. And guys, my recommendation, like if you want to have a decent laptop, don't worry about the battery. Like if you're worrying about the battery, then buy the MacBook simply. So don't worry about the battery first. Means if you game a decent PC, decent laptop that will work like a horsepower, then it is not going to give you a backup. The maximum you will get is 1 hour. Just forget about the backup. The next thing is that if you are looking for a workhorse kind of laptop, always buy from Asus. I think Asus have the best justified prices in the laptop categories, and they also have a very build quality in gaming categories. Even if you buy their beginners gaming laptops, those are enough to run SolidWorks. So HP, Dell are okay, but they are not very good in when it comes to performance and things like that. Anyone
Sir,
have any more questions?
Sir, you know CATIA NX CAD software, sir?
No, I only know 3 softwares at this moment: AutoCAD, SolidWorks, and Autodesk Fusion. I also know Inventor Basics. I know Blender 3D, but I don't know UGNX, CATIA, because I never worked with automotive industries. Most of my career I had worked in the mechanical layout industries, like planning factories, like plants, chemical units, chemical plants, cement plants, and the things like that. So those industries, they are not really using CATIA and UGNX. Mostly the product oriented companies like aerospace or automotive companies, they are using tools like CATIA and UGNX. But if you want to learn NX, we have a community where a very good mentor is running workshops like this that I am doing on NX software, and he's working in Siemens right now, and he's doing so many similar kind of trainings and stuff like that. So once this training will be over in the next week, I think the next week the date will be around 19th or 18th of August. I will be closing this group, and all of you will be transferred to our main group, that is CAD community, where already more than 900 members are there, all engineers, designers. So you all will be added over there, and from there you will be getting all kind of updates related to different softwares also.
Okay,
So,
sir. Okay, sir. Thank you, sir.
Any more questions? Okay, so I think we are done with
Future
it.
will class.
Yes.
Okay. Futurely, we will be classes teach me in this group, sir.
Sorry, I'm not getting you. You can ask in Hindi as well, like if you're having any problem.
In India, I don't know, sir. I am Tamil Nadu.
Okay. Okay. So what is the question? Repeat.
Futurely, will class you teach me?
Voice is breaking.
Will
Can you write into the?
Futurely, class.
Okay. So future classes you are asking.
Yes, 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 yes.
See, this was like a 7-day continuous live session, right? Apart from this, we also do so many mentorship sessions, free sessions related to product design and engineering. All those updates you will be getting into the main group only. Like we are even today also from 9 p.m. A free class is going on about NX. So but that, all those updates you will be able to get on into the main group only once this live stream, this boot camp, this was the last session today. Once this is over, we'll transfer all of you into the main group, so you also will be getting updated.
Okay, sir. Thank you, sir.
Thank you. Thank you so much, Sundaram. Thank you so much, Oidran. I think he's from Africa. He also joined our class. So thank you so much, guys. Again, we'll
Thank you so
upload
much,
all
sir.
the recordings and the contents to our channel, to our YouTube channel, to our dashboard. So you will be watching over there as well. See you guys. Thank you so much. It was a great time learning with you.
Thank you, sir. Good night.
Thank you. Good night.